Welcome to myprojectbazaar.com. Our product title is 3-base LLC series resonant DC to DC converter using SiC MOSFET to realize high voltage and high frequency operation. Next we see about abstract of our product. In this proposed implementation we using special MOSFET device. That name is SiC MOSFET. The main difference between the normal MOSFET and SiC MOSFET is the PV rating of voltage is 1200 volt, and this design does that SiC MOSFETs are applied to constitute a 3-base 5 kW LLC series resonant DC to DC converter with isolation transformers. A switching frequency of around 200 kHz for the transistor successfully reduces the volume of these isolation transformers, whereas insulated gate bipolar transistors are not capable of achieving such a high switching speed. The high voltage tolerance of SiC MOSFETs 1200 volt enables increasing the input voltage up to 600 volt. High voltage tolerance on the other hand is not compatible with low on resistance for SiC MOSFETs. A 3-base circuit topology is used to capacity for the converter and reduce per phase current at the same time. Current balancing transformers among these phases effectively suppresses a maximum pulse peak current from arising in the circuit, a technique that miniatures the input and output capacitance. The conversion efficiency of the converter reaches 97.6% at 5 kW operation. This implementation is done in MATLAB simulating environment. Next we see about flow diagram of our product. This is our flow diagram. Generally the input source is a DC supply. The DC supply is fed into the LLC resonant converter with mutual inductance, and this LLC resonant converter having SiC MOSFET switches and LLC resonant converters and mutual inductance. In the MOSFET switches is getting the pulses from the PWM generator, and this PWM generator used to generate the pulse. The technique name is short switching technique. There are two kinds of short switching techniques. They are ZVS and ZCS. ZVS is zero voltage switching technique and ZCS is zero current switching technique. Among that, the pulses is generated and fed to the SiC MOSFET. After that, the mutual inductance is connected between the load side and the input converter side, and the LLC resonant converter having capacitance and inductance according from the resonant network. And after that, the load is a resistive load. The load is connected in between the converter and mutual inductance. Generally the PWM generator having lot of PWM techniques. Here we using soft switching technique. The main objective of soft switching technique is reducing the switching losses and switching stresses also, and due to using of soft switching technique the converter life will be increased. The resonant network consists of a capacitor, leakage inductance and the magnetizing inductance of the transformer. The resonant network filters the higher harmonic currents, thus essentially only sinusoidal current is allowed to flow through the resonant network. Even though a square wave voltage is applied to the resonant network, the current lags the voltage applied to the resonant network. That is the fundamental component of the square wave voltage VD applied to the half bridged, which allows the MOSFETs to be turned on with zero voltage. As can be seen, the MOSFET turns on while the current is flowing through the anti-parallel diode, and the voltage across the MOSFETs is zero. The rectifier network produces DC voltage by rectifying the AC current with rectifier diodes and capacitors. The rectifier network can be implemented a full wave bridge or center tapped configuration with capacitive output filter. The filtering action of the resonant converter is filtered the unwanted harmonics in the output side. Next we see about running process of our product. In this proposed implementation is done in MATLAB Simulink environment. The version is MATLAB 2013A. First open the MATLAB window and create a new model file. After creating the new model file, we select the Simulink library browser. In the Simulink library browser, various elements are there. Whatever we record for our circuit, that elements are tracked into the saving files. After arranged the elements as per the circuit, we click the run icon. After that, the output voltage, current and corresponding parameters are displayed in the corresponding scopes. First we see the output voltage and input voltage, input current for single level LLC resonant converter for using SiC MOSFET. First one, output current of single input level, and next one the voltage of the SiC MOSFET for using single level resonant converter, and this is the output voltage for the single level resonant converter. The output voltage range is 55 volt and that range is is constant voltage after some duration. And next one the output current, the value is 5.5, so the resistance value is 10 ohms, and this is the pulses for given to the corresponding SiC MOSFETs in the corresponding leg in the converter. And next one the output current waveform for using of 3 level LLC resonant converter. After that we saw the output voltage for the 3 level LLC resonant converter. So the range is nearest 300 to 350. So the constant voltage can be attained, but some variations is secured due to the resonant components. And overall the harmonics will be reduced by using of short switching technique. Thank you for watching this video.